And hello everybody to our session on efficient calibration data management, managing variants. My name is Michael Vogel, I'm Senior Product Manager at Vector, and I'm accompanied by Christian Wilhelm, one of our senior engineers and product experts. So there is room for your questions. We love to get in touch with you, get your feedback, hear your questions. But with the audience in this session, we ask you to put your questions to the end. Right, let's just get familiar with the topic. The calibration of electronic controls became very complex over the past years for many reasons. Now, this example shows the complexity increase of an engine powertrain ECU. Now, adjacent domains such as chassis or body are often simpler in terms of number of calibration parameters. Nevertheless, they face the problem that the number of calibration variants is significantly higher. So the effective only way to manage calibration data, to have visibility through changes and provide consistency across variants and high quality, is using a professional calibration data management. So SVN-based solutions, as an example, fail because they are file-based and you really need to manage calibration parameters. And solutions such as Excel fail because they don't support the data types that you typically have in automotive, such as curves and map. You really want a proper presentation to deal with these data properly. A calibration data management system provides a central install that supports the complete process in a structured way. It accommodates teamwork and provides visibility, progress tracking, and quality management. So typically, there are work phases where you create calibration variants, set up work packages, deal with permissions, who is allowed to change which parameters and things like this. Then there is the calibration phase in a vehicle or offline with various tools, in-car, canopy, ATI vision, or proprietary tools. Then the calibration data is brought back from the engineers into the central system, and typically you have a review process, you approve calibration changes, and you create an hex file for the next iteration of the exercise. So this core process is supported by workflows, event management, emails, reporting, and analysis capabilities. But apart from this core process, there are many supporting processes that a calibration data management system supports, and it's, for instance, creating a project in the first place, but then, of course, syndicating content into foreign systems such as SVN systems, PLM systems, ALM systems, production systems. It's the whole infrastructure of an enterprise. And obviously, one important step is changing the software and actually bringing as much calibration data in the new generation of the software, not losing precious work. So today's session really focuses on managing variants, and it's actually the core strength of our product. So let's take a look at what this actually means in reality. So what do I mean if I talk about the calibration variant? So it is an identical controller software, but with partially different calibration data to reflect the different characteristics of a vehicle. So as an example, a 2-liter engine with an automatic transmission or a manual transmission. So these two controllers have different calibration parameters. Now, what does it mean in reality? So one of our customers, it's a European car manufacturer, and as an example, for his 1.8-liter engine, he runs 27 different calibration variants for the engine built in different vehicles, different emission classes, and different transmissions. A European transmission manufacturer, his 6-speed gearbox has 88 different calibration variants because the gearbox is used in many different OEM vehicles all over the world. And finally, a chassis manufacturer. So he provides a park assist system, and he has to deal with 1,200 different calibration variants. Right. Now, managing variants is the core strength of our solution, and vCDM provides many concepts and methods to help you to master the complexity and maintain a high quality and consistent calibration data for your product. In this webinar, we will introduce you to the main concepts and outline their benefits. So many concepts can be used together with other concepts, so that at the end you have a very high sophisticated variant management system to easily help you to maintain consistency, transparency across your variant. Okay, now it's all pretty theoretical at the moment, so let's just start with a very simple example to get warm. So let's say we have a project of an engine with two different emission classes, and the emission class is just controlled with two calibration labels. So each emission has two different performance classes of the engine with 100 and 120 kilowatts. And some of these have automatic transmissions, some of them have manual transmissions. So it's a pretty decent project. It's just 6 calibration variants and just 4 calibration labels. Now, if we take a look at the calibrations, they are outlined here. Now, just imagine one of your engineers comes and tells you, hey, I think we have a problem with our calibration. Now, you probably take a while to find the mistake here. And just imagine what this means in reality if you have to scan over 80 columns and 20,000 labels. Now, actually, at the end, you will probably find that in this simple example, the label actually has to be free. Now, what was the reason for this problem? Was there a mistake by the calibration import? Or did we set up the dependencies of the attributes wrong? Or what is actually the problem? Did we use the wrong component? Well, actually, is it a problem at all? Or maybe we've designed the project structure wrong? So that is quite an important question. Now, Christian, I'm just wondering, could you please show the audience what possibilities vCDM provides to get a good understanding on the data?
Okay, thank you, Michael, for the short introduction. Before I answer your questions, I have to share my screen. And want to ask if anyone can hear me? Yes, I can. Okay, thank you very much for the feedback. Okay, let's start with a feature which is called variation reports to answer your question, Michael. How to get a rough overview over my current calibration data and its variants. So we have many reportings in vCDM. We could do an own webinar about reporting. Also, we are thinking currently about doing such a webinar. But today we want to focus on the variant report. You can start it from the ribbons out of the analysis and reporting menu. There you will find an icon which is called value population metrics. And if you click on it, then you first have to select a project. Then you will be asked over which vehicle variants you want to do the population matrix, and afterwards you can filter for some labels to get the overview on. If you click on finish, then the value population matrix will open and it shows you some information. On the left side you see the labels you selected in the step before. And on the top in the columns, you see the vehicle variants you selected. And now in the third column, you see number of variations, which means this label has 3 different calibrations in these data sets on top on here. You also can see this if you have a look on the color of the cells. Then you can see there are 3 different colors, and each value is colored in the same color. So you can have a very quick overview over areas which have the same value, but also over areas where are different calibrations for. So if you search for an error for a mistake, maybe you have to look in this region because there seems something wrong. You additionally have the option to filter these rows here by selecting, deselecting these checkboxes. And you have the possibility to filter over variants. If you see, okay, my first variants here are okay, then you can filter here by product attributes, so you get the better overview. Also, a very interesting button is this one, which will show you only the rows which have different variations. So it will uncheck these 3 boxes because we only have 1 variation here and only shows the first 2 lines. If you go onto the parameter value report, it's nearly the same data you can see here, but in a different layout, let's say. So here on the first level, all the labels are listed again, and underneath each label, you can see the different calibrations the label has. So if I would toggle here between these 2 lines, then I can see one time the value is -4, next time it is -3, and in this window I can see in which data sets each value is used. So you can get a very fast overview over your calibration data.
All right, thank you. That's very powerful. And as you said, we could spend a webinar solely on reporting and analysis. Now, Christian, calibration is an iterative process, and engineers deliver files over time, and they have continuous improvements. Now, how can the product actually help calibration engineers to assign calibration files to the proper calibration variants?
Okay, here helps another feature, which is called calibration metrics. Calibration metrics also first how it is being executed. You can start it again in the ribbons in the menu view, clicking on calibration metrics. Then we already had these 2 screens in the feature before. You first have to select the project on which you want to have the calibration metrics opened, and again you can filter by data sets. As you can see, I checked all here. So if you go on the next slide, the calibration metrics is being opened. And as you can see here, on the left side, first all work packages which are used in these data sets are listed. And if you have a closer look, then you will see that work package 1, in example, is listed twice. This is because work package 1 got 2 delivery files. One time it was the work package 1_1, and one time it was the work package 1_2 CDFX. In the cells after these headers, you see again our data sets, our dataset variants here in the top, and these checkboxes now mark for which work package which file was delivered. So you can very quickly see where your delivery files, in which datasets your delivery files went to. Also here, the same as before, you can filter work packages, so reduce rows, and you can filter datasets, so reduce columns. And again, this little helper button, multiple variants, if you click on this, then you will only see work packages where at least 2 different variations exist. So this is getting the overview. But the calibration matrix also helps you delivering files. So this is the question you asked before, Michael. If I want to deliver a new calibration and replace an already existing calibration, then I just click the upload button and say replace an existing work package. Then for sure in the next step I have to select the file I want to deliver, so in this case a DCM file, And then the assign parameter set dialog opens, and as you can see here, there are two datasets pre-selected. This is because this old file was already included in these two variations. So the dialog already helps me assigning to the correct variance. If I go on the next screen, then you can also see the calibration matrix is not only a report, but it's a GUI interface where you also can interact with. So you can set these checkboxes you see here. You see that they are enabled, so I can click on a checkbox. An example, here's work package 1, which has one time a placeholder, which means it's never got any delivery in this data set. So imagine this checkbox was here. If I now click in this checkbox, this means that please put also this work package 1_1, 1_2 in this variant 2. So these two cells are marked in orange because this is a change. Drop out placeholder, put in work package 1_2 CDFX. And then the user has the possibility to click this validate button.
And what actually happens if you click validate?
This depends on your project settings. You can set up different validations on your project for delivery. Actually, technically, it is done a delivery without persisting in the database, let's say. So every execution step is done, and if there are any warnings or errors, then they will be reported to you. Otherwise, it just will turn green, so it's pre-validated. And then you can just do delivery by executing, by pressing the OK button.
All right, thank you very much. Understood. Now, what we actually didn't highlight in the beginning is that calibration variants are not just simply a string. Yeah? When we create calibration variants, we assign attributes to them. And for every one of you who is not familiar with the product, I encourage you to just revisit the webinar on vCDM itself. Now, with variants assigned, or with attributes assigned to the variants, is there a way to really have an automatic algorithm to assign these deliveries automatically to the variants?
As you may assume, sure there is. So let's have a look in the next feature slides. It's called the component library. So you may think of each CDFX file, each delivery file is a component library. It contains several labels. They have a value, so it's a library with values, you can say. So let's just call each CDFX file in this example here a component library. This is the component library emission EU, which contains two parameters, and this is the component library emission US, which contains, again, two labels. As you already heard, these component libraries are typed. So I said this is the component library emission EU and emission US, power 100 kilowatt, power 120 kilowatt, and so on. I can also think about combining these two emission component libraries into one huge emission component library. Do the same for power, do the same for transmission. And also I can think about also do a component library around these three libraries and give it a speaking name, like this was my values from last summer, or these are my good starting point for new projects, or something like this. And then imagine you can send these component libraries to projects, which means if I click on this button, then automatically this emission EU CDFX file is being delivered into variant 1 because of variant 1 is a dataset which has emission EU, and this component library also has emission EU. So the CDFX file exactly knows where to go. Same for emission US, this goes into variant 2 because it's emission US, and so on. Power 100 kilowatt goes into variant 1. Power 120 kilowatt goes goes not in any dataset in my example here, but again, power 140 kilowatt goes into variant 2, and so on.
Okay, great. So at the end, I can have a library of golden calibrations and really have a very fast initial calibration of my controller software. How much effort is it to set up component management in vCDM?
That's just easy. I've noticed this on the next slide. So again, you will find in the ribbons a ribbon which is called Data Management, and there is a button New Component Library. This opens the wizard. The first step is to give my component library a name. You can type in anything here, it doesn't matter. But the next step in the wizard is to assign attributes to this component library. In this example, I assign the attribute transmission automatic to this component library. If I then click Finish, a new container is being created, a new component container, which has the CDM product attribute transmission AT. So it's an attributed container object. Container object in vCDM means I can put anything else into a container. So especially in the comp container, I can put delivery files. As you can see here, we have again our transmission AT component library, and here I drag just a good starting point, my two CDFX files, into this transmission AT container. You also for sure can import files from disk and so on. As you also can see, I have here a second transmission empty container, and you can see here I've used speaking names for the CDFX files. So transmission empty CDFX files are in transmission empty, and transmission AT CDFX files are in transmission AT. Again, you can see here the attribution of the two component libraries. One is AT, the other is empty. And also you can see here both transmission libraries are in a bigger, also called transmission library. So I put these two together into transmission. And then in the next step, I could select this transmission library and say, please send this to a project. Then again, these dialogues open, you already know them. You first have to select the project. Then you have to select a software variation. This is ECU software container. Each dataset is created out of a software container. And then you may filter for dataset variants, but you also can say select all. It's okay for next step. So what happens now is that a small preview dialog opens. It looks just very similar to the dialog we have seen before when we talked about calibration metrics. So you have the delivery files as cell headers, as row headers here in front, and then you have again the variations on top. And now you can see the two delivery files, A2CDFX, ATCDFX, go into variation 1. If you hover these columns, then you also can see the attributes of the dataset, and then you see why these files are delivered into this variation, because it's transmission AT. And the same for transmission empty CDFX files. You can also see these go into variation 4, an example, because this is transmission empty. The user has the possibility to uncheck these checked boxes. In an example, you could say variation 1 is only my testing vehicle. I don't want to up this right now, but normally I think you would leave this exactly like shown here.
Okay. So every parameter gets a fixed value depending on the component that applies to him. What about parameters which apply to certain rules? So as an example, a software function uses the radius of a wheel, and another function the diameter. And as a calibration engineer, I want automatically that one parameter is twice the other parameter. So actually I'm looking for a way to calculate my parameter values.
Okay, this you can achieve with the next feature, which is called parameter values or parameter value checks. There's a small difference I will explain to you later. But first, how do I set up them? Parameter value rules and value checks are provided on the properties page of a project. So I open the properties of a CDM project here. and there you will find a tab which is called Parameter Value Rules. Then next you have to choose the software version again, where you want to define parameter values for. And then clicking the Add button, you can add all the parameters you want to define a rule for. So if I choose one label here and press OK, then it will be listed here in the parameters list. Then in the next step, you have to click a single parameter, and then you can specify your rule here in this scripting window. You don't have to start on the blank ground, but you can use this button New from Template. The next the template chooser opens, and as you can see here, we provide with the product already some templates. Just have a look at the first one, which is compute current hex parameter value. So you could think about getting a value out of the hex file and increasing it by 1. This is the example you can see here. Or this is a computing script which returns the current time, the current username. This is just empty. This returns a specific version attribute. You will see this later. And also you can see here are some testing scripts. The testing scripts give the possibility to test the value. We will see it later. Also here are some templates, test against the current hex value, test if the curve is increasing or decreasing, testing against min values, and so on. So you could choose one of these templates, press OK, then the template is listed here, and then you can modify it. Just have a look on an example for parameter value rule. If you want to implement a parameter value rule, then you have to implement iParameter value rule script, which contains exactly one method, which is called compute parameter value, and provides us back an object, which is the new parameter value the parameter shall get. And as input parameters, there are some environment parameters, but also the dataset ID. The rule later is being executed on. So then in the script, you can see first some objects are retrieved, and then the version attribute engine is retrieved from the dataset. So in example, 150 kilowatt. And then the next step, it is tested. Does it has a value? If not, we throw a speaking error like the dataset version attribute engine is empty. Or if this is not the case, then we just looking at this value, replacing kilowatt by an empty string in example. So we then have 150 as string, parsing it as double, so as a number, and returning this value. So if you execute this parameter value rule later on a data set, then this label, array element 0, will get the value which stands here in this engine product attribute. Next, there is an example for parameter value check. So here you have to implement a slightly different interface, which now has a method test parameter value, which returns a Boolean. A Boolean is true or false. So it says it is a good value or it is no good value. As input, you get a parameter value, and as you can see here, you can feedback a message. As soon as you say no, this is no good value, you should say why it isn't a good value. So again, here in this example, a version attribute transmission is retrieved, and here you can see a test if the version attribute is empty. So if we have a manual transmission and the value is higher than 10, then we throw an error, so we're returning false. This is no good value because transmission is manually expected the value of less than or equal 10, but was 12 an example. Here the other way around, if we have an automatic transmission and the value is lower or equal to 10, then the transmission is automatic, expected the value higher than 10, but was 8 an example, returning false. In all other cases, we just return true, which means this is a good value, everything is okay, we go on green. Go ahead.
Well, that's very powerful, but actually I'm a little bit afraid that you lost me. It's really complex, so I'm not sure that I could create such a script. So what possibilities are there for our customers?
Yes, for sure you're right. most likely you will need some programming skills. But therefore, you get the highest degree of freedom, and you can not only access information out of vCDM, but you can also think about parsing specific documents on your network drive, calling XML web services, accessing other tools on your workstations, and so on and so on. As already mentioned, there are templates you can start on. So these few, they for sure will increase with the time. But also maybe this script could come from your software development, because they know which label depends on which artifacts in your system. So maybe you can ask them. And if they can't help you, then I've noticed it here, we can help you to start. Just give us a call and we try to help you. We also have commercial offers. One is called premium support. We can give you on an hourly basis support. So this is no problem starting.
Okay, so the idea is not that calibration engineers create these scripts, but experts. Now, how does it look for the calibration engineer if he actually applies these scripts?
How to apply scripts is very, very easy, Michael. As you can see here, just select a few data sets, all data sets you want to execute these rules on, and then click right mouse button, data set, execute value rules, and that's it. Then all the specified rules are executed on these labels. You will then get a little progress. Maybe the progress shows an error, which then most likely will not be an error by vCDM. So have a look in all messages, and all messages is a little bit more speakier than the progress dialog here. As you can see here, this is my first example of the parameter value rules. Executed on many data sets. He says for variant 3, setting value for parameter array element 0, new value to 150. For variant 2 is the new value 120. Variant 1 is the new value 120. These are the kilowatt numbers of these variants. So everything's green here, everything's okay. This is the example for the parameter value check we've seen 2 slides ago. So here we see some errors, which doesn't come from vCDM, but from the script. And you can see here, the transmission is automatic, expected a value higher than 10, but was -2, for example. Maybe we have a look also on a list of scripts from another customer from us. It's Daimler AG passenger cars. They have a lot of labels they call logistic data. And as an example, there is a label which I get the value out of a dataset version attribute, which is called part number. They hold the part number data at the dataset, and this label becomes gets exactly the value out of part number data. It's another label with dataset revision, with the current week, with the current year, and so on. Many examples. Here's a user example. Okay. Also, these rules here, you see it marked with 1. The values not only are provided to the single parameters, but also stored at dataset inversion attributes. So as mentioned, you can do everything you want to here in the scripts. You can also modify the dataset for sure. And as you can see marked at these number 3 here, these parameters are later used for generating the hex naming. We have another feature in vCDM which is called hex naming rule. You can build up the name of the hex file by using, in example, parameter values. And for Daimler AG passenger car, this means they have consistency not only over parameter values, they are correctly having correct value, but also on some version attributes on a data set and the hex file name. So everything is consistent after they pressed execute value rules. In addition, Daimler AG passenger cars using the vCDM web client, and in the vCDM web client you can search datasets also for version attributes. So now everything is one world, one thing, everything matches together, and they are sure they have good data.
Okay, thank you. Now, consistency, that's actually the point where my next question is. So let's say I have two calibration variants that have only really minor modifications. So a typical example, you have a configuration of a test vehicle, and if you bring the test vehicle on the roller bench, you actually need to apply a couple of calibration difference to disable security, enable the automation system. Now, these variants are almost identical. Actually, I want to have them identical, except these minor differences. Now, is there a way to achieve this easily?
Okay, here helps the feature derived variants. Derived variants, again, first how it works, how to set them up. As you might know, normally you create new data sets on base of projects. Normally I would say new data sets during selecting this project. As you can see here, I select a data set, and on this data set I say new data set, and this one is called a derived data set, create derived data set variant. The next dialog most of you might know, it's just the normal dialog which opens when creating data sets. I have to choose a product key for the data sets to create. And as you can see here, the names in my example are derived 1, derived 2. So if I would click finish in this case, then you for sure see your base data set here, but also these two derived data sets. And if I have a closer look on derived 1, then you see here that the derived 1 dataset contains the base dataset. So a dataset contains another dataset, which means this dataset derives from this base dataset. If I have a look on the calibrated content of the derived dataset, then I will see also, although I have done no delivery onto derived 1, I will see some calibration data. This calibration data is listed in gray text color, which means this is not directly calibrated in this dataset, but it is inherited from the base dataset. You also can see in this column, here is a column called dataset, and there you can see, this value comes from the base dataset. But for sure, you can also modify data in the derived dataset. Then I've done here a delivery with exactly this parameter and set all the cells here to 1, all the values to 1. Then the parameter is listed in black now, and as you can see here again in the column dataset, I now can see the value is directly calibrated in derived 1.
Okay, I see. So basically, enabling an automation system is delivering one parameter files, and it's overwritten, and I just need to maintain actually one data file, and I have two different variations. Okay, that's great. That's great. Now, you already talked about assigning delivery files to calibration variants semi-automatically. But often delivery files contain hundreds of labels, and each one depending on different product attributes. So how do we deal with this?
Okay. Now we come to the very complex feature, which is dependency management. It's not quite easy to understand, but I give a try. So first, again, how to set up this feature. Dependency matrix is provided on base of a program set now. So a software has a dependency matrix. If you go on the properties of a program set, if you configured everything correctly, then you will see an attribute dependency label. And on this screen, then you can set up the dependencies of labels. So you can add labels here into this list as a row, and you can add product attributes as column here. And by selecting these cells here, you say this label depends on this product attribute. So in my example here, area element 0 depends on, and solely depends on the attribute engine. A little bit more complex example is air mass X table here in the screen. It depends on emission and transmission, which means it depends on the combination of emission and transmission. So an example, Emma's X table must have the same value in all datasets, in example, which are EU5 and MT, so which have a specific emission and transmission combination. And the good news here is also, maybe you have 20,000 parameters and 30 product attributes you don't want to do this in this dialog. There's for sure also a COM API, so you don't have to do this in this dialog here. It's just getting a rough overview. Also, this dependency matrix may come from your software development department, because they again know which labels depend on which product attributes. Okay, so this is the most complex thing to understand for the dependency matrix. And now why you should do this? First of all, with dependency management, it makes your delivery very, very easy and very fail-safe. So importing calibration files, normally you would select one or more data sets and deliver calibration files into these data sets. As you can see here, now I've selected a complete project to import calibration files into. I don't select a single data set, but a complete project. But it's the normal delivery wizard, so you may also know this page. For sure, I have to first again provide my delivery files. And now let's assume this file contains only labels which directly depend on engine. Then the next page, this is now dependency management specific. The next page, the delivery wizard will ask me on which engine do you want to provide this file. It doesn't ask me into which datasets I want to deliver, but it asks me in which engines I want to deliver this file. So here I check the checkbox 100 kilowatt, and then the delivery wizard only shows me the information. Okay, later I will put this, I will deliver this file into these variations because they have 100 kilowatt engine. So the wizard asks me the correct information. As you can see here also, it doesn't ask me about emission and transmission because it is regardless if my label only contains parameters which depend on engine.
So Christian, in your example, it's just one delivery file that contains label that depends on one product attribute. Now in reality, it's big delivery files, and every single label depends on different product attributes.
Yes, I've had an example on the next page. So let's assume here that now someone delivers a complete CDFX file, which means it contains all the labels of the software. So many hundreds and labels. Then for sure the delivery wizard will ask more information. Here he wants to know what emission, what engine and transmission should I calibrate. And then the delivery wizard does a little bit magic. He splits up the complete CDFX file into 5 other smaller CDFX files. So we have a complete emission CDFX file, complete engine CDFX file, complete transmission CDFX file, and so on. As you can see here, complete transmission CDFX file. This CDFX file only contains labels which directly and solely depend on transmission. And in the next step, the delivery wizard will deliver this file into variant 1 and variant 3 because these two datasets have transmission 80, and the user said, please deliver this file to transmission 80.
Okay, and if there are now multiple dependencies?
Yes, if there are labels with multiple dependencies, you can also see here 2 other files. They are named complete emission transmission CDFX, which means in this file all labels are in which depend on the combination of emission and transmission. Again, this file is delivered into variant 1 and variant 3. Why? The user said, please deliver all labels out of this file which depend on emission and transmission into all vehicles with EU4 and 80. So variant 1 is EU4 and 80. Because of that, the file goes into variant 1. And variant 3 is also EU4 and 80. Because of that, the labels go into this. They don't go into variant 2 because variant 2 is EU4, okay, but it is empty, so the delivery file is not put in here. Delivery is not the only feature you get out of the dependency management. You have also a feature which is for checking consistency. You can find it in the reporting menu in parameter dependency report. Normally, if you only use the delivery wizard with dependency management, you can't get inconsistencies because it is designed to deliver the correct labels into the correct data sets. But for sure, we leave all the other product features open, so you can still deliver directly labels into a data set. You can edit the data set, you can execute parameter value rules, you have access to the COM API and so on. So you may cause, other features, you may cause inconsistencies. But at some time you want to ensure that you don't have inconsistencies, so we have this parameter dependency report. You again started on a project, choosing a software and selecting some or all variants. And then a dialog will open, which shows you where inconsistencies are. So normally here's a filter on, which says only show me inconsistency entries. And this entry means I have an inconsistency in area element 0 for data sets of 100 kilowatt. So I have two variations where I only should have one variation. And if I toggle here again, then I can see one time the value is -3, the other time it is -4. And here you can see which data set caused the inconsistency. So these three data sets have the value -3, and this data set has the value -4 for this label, but all data sets should have the same value because all are 100 kilowatt. So this is an inconsistency.
Okay, so I really have the possibility to ensure my consistency at every point in time of the project. That's very powerful. So what are you doing if you find out, hey, I do have inconsistency?
Yeah, okay. As I mentioned, you could do an edit data set on most likely on this variant 1, because most likely this is the one which has the error. But you could also, we could also use the next feature, also dependency management. This is generate values from existing data sets. So you could also select variant 1 and open the context menu data set and say generate values from dependencies. What then happens is it opens a dialog which shows you you want to target variant 1 and to want variant 1 to be calibrated like all these other data sets here. What then will happen if you press OK, you will see that variant 1 is being updated, and you see here array element number 0 generated from parameter dependency. So this label in variant 1 was calibrated automatically by the dependency management. How does this work? Let's have an example here. This is dependency metrics we've already seen a few slides ago. And now let's assume we have already two calibrated variants, variant 2 and variant 3, with this calibration content for variant 2 and this calibrated content for variant 3. And now let's assume variant 1 is completely empty. And the user now says generate values from dependencies on variant 1. What's happening now? First, it takes the values out of variant 3. Why? Variant 1 is an emission EU4 and automatic. And these two labels depend directly on the combination of emission and transmission. This means I can take the value out of any data set which is also EU4 and 80, like, for example, variant 3. So I can take this XX and YY out of variant 3. Let's go ahead. It will also take these values out of variant 2. Why? These labels all are dependent directly on engine. And variant 1 is 100 kilowatt, same as variant 2, it's also 100 kilowatt. So I can take all the values out of variant 2. In the last step, I can take these 3 values out of variant 3 because these labels depend on transmission and both data sets are automatic. So I can reuse the calibration out of variant 3, which means with only one click in 1 second, you get a complete 100% completely calibrated variant 1 out of the calibration of other data sets.
Okay. Thank you very much, Christian. So that's a very powerful feature. I understood that basically you can automatically calibrate the complete calibration. So we're coming towards the end of this hour.